At 400 Kelvin, the pressure of octane is measured and found to be lower than the pressure predicted by the ideal gas law. Is this related to the invalid assumption of volume or temperature? Well, given that the real pressure is less than the ideal pressure, then this can't be due to the invalid volume assumption, because the volume of a real gas particle is greater than the volume of an ideal gas particle, which is treated as a point. And this would result in a higher pressure of the real gas compared to the ideal gas. So the answer is due to the invalid assumption of temperature. And just to give you some perspective, 400 Kelvin is around 127 degrees Celsius, and this is near the boiling point of octane. So therefore the deviation from ideal conditions due to temperature means that the gas is near condensation conditions. Under the following conditions, the real pressure and temperature of argon gas are measured as follows. Now, under which condition is argon most likely to deviate from the ideal gas law? Well, for a lower temperature, the gas particles are going to be traveling at lower velocities, so the intermolecular forces become significant. And for a higher pressure, the particles are going to be more clumped up together, and therefore the volume of the gas particles causes deviation from ideal conditions. So for case B, the pressure is the highest and the temperature is the lowest. So this is the case that's likely to cause the most deviation from ideal conditions. Octane is more polarizable than water vapor, which is H2O in the gas phase. Which substance is then most likely to deviate from an ideal gas, and why? Well, for octane, the intermolecular forces between the molecules are London dispersion forces, as the molecule is nonpolar. And between H2O molecules, you have hydrogen bonding, which is a special type of dipole-dipole interaction. So given that octane is more polarizable, given that the molecules are significantly larger than H2O molecules, then the intermolecular forces between the octane molecules are going to be more significant. And therefore, octane is most likely to deviate from an ideal gas.